Hey guys, here's your homework for geometry for tonight. This is due on March the 13th in class, and we're just doing the odds for class. So you're going to see that I'm going to do a whole lot of the evens, as many as I can actually. And this problem number 6 is the same as problem number 4, which we realized in class today. So I'm not going to do it twice. So let's go ahead and let's get started here. Remember what we talked about as far as the different shapes. And I'm going to go over and I'm going to do another YouTube video that reviews what you need to know for the quiz that we're going to have on Thursday as well. I mean Wednesday. Wednesday's the 13th, sorry. So let's start right here on number 2. And in number 2, what shape do I have? I have one pair of parallel sides, and I have one pair of non-parallel congruent sides. So this is an isosceles trapezoid, just like they've said in the directions. I'm going to zoom in now, because I have students that complain if I don't zoom in. So here in this problem, what do we know about an isosceles trapezoid? One, we know that the base angles are congruent. Well, what are my bases? My bases are the parallel sides. So I know that this angle is going to be congruent to this one. And I know that this angle is congruent to this one. Okay? So easy problem. Angle 1 is 109. So angle 1 we know right off the bat because those two are congruent. But those of you that may still be struggling, I want to point out here we have two parallel lines, right? And then we have this transversal. And maybe I'll use a different color even. We have this transversal going right here. So think back to those, the transversal and the parallel lines and the interior and the exterior and the alternate interior, and these two are on the same side of the transversal, and they're both inside the parallel lines. They're interior, same side. So same side interior angles. And we know that same side interior angles are supplementary. So we have this angle 109, and we're going to add whatever this angle 3 is. And we know that together those guys are 180 degrees. So I subtract 109 from both sides, and what do I get when I do that? I don't even have a calculator over here. I'm going to have to pause and run and get one here in a second. But that's going to give me, what, 71 degrees? So that means angle 3 is 71 degrees. And because angle 1 and angle 2 and angle 3 are both base angles on the same parallel line, we know that angle 2 is also 71 degrees. So I hope that helps you here on 3 and 1, because they're very similar problems. All right, now let's jump down here to number 4. Now, I want to remind you of the formula I had you write down, where we found out that the mid-segment, which is this line right here, is going to equal the average of my two bases. So we have this base and this base. So we have base 1 plus base 2 divided in half. Isn't that the average? You add two numbers and you divide by how many you have. We also could put our parallel lines here, but we know they're parallel because it tells me it's a trapezoid. So what would my equation look like here? Well, it would look like my mid-segment, which is, let me do it in the right color, 3x minus 6, is going to equal my two bases, 2x minus 1, plus, because remember we add them together, 25, and that amount is divided by, how many bases do I have? 1, 2. So we find the average. And then you would solve that problem. How would I do that? Well, the first step would be, I've got to get this 2 out of the denominator. I don't want to leave it there, so I'm going to multiply the whole thing by 2. Now, 2 over 2 equals, any number over itself is equal to 1. So that's going to be gone. I'm going to have 1 times this quantity, which is fine. But what I do to one side, I have to do to the other. Now notice there is no denominator here. So in fractions, we just multiply across. Our numerators are going to multiply. So I'm going to have 2 times 3x, which I'm going to get 6x. Oh, I'm off the paper now. 6x, that's this one. And now I'm going to multiply over here. 2 times negative 6, that's negative 12. And that equals 2x minus 1 plus 25, that's going to give me 24. Is everybody okay with me combining these two things in this step too? I think that you guys can all handle that. I want to get x by itself, so I'm going to subtract 2x on both sides. And now, if I were really being fastidious, I would just add those up and do another line, but I'm kind of short on space. So my other step is going to be add 12 to both sides. Now when I do that, 6x minus 2x, that is 4x. Minus 12 plus 12, that's 0. 2x minus 2x, that's 0x. And 24 plus 12 is 36. Divide both sides by 4. X equals 9. And it also wants me to find the length of GH. So I'd have to come up here and plug my 9 in to the x value. So 3 times 9 minus 6. So 27, 3 times 9 is 27, minus 6, and that equals 21. So I know that GH is 21. Similar problem for 5. Similar problem for 10, 11, and 12. Of course, you're just going to do 11 down here. So you have two problems like that one we just did. So if I were you, I would just do 5 right now, and then I would jump down and do 11, because you want to make sure that you can do those problems right next to each other so you're not as confused. Okay, let's look here at these problems. It wants me to find, now what are we talking about here? Angles, right? And all three of these, all of those are angles. Well, these two are angles. These are sides. So we have an AC and we have a BD. And you might want to look at your property charts because we have a couple of congruent things there. And so when we have two congruent things, that's your equation. You identify the two things that are the same, which is exactly like what we're doing here. We know this angle and this angle are both base angles. No, I covered up the 3, so I hope you can forgive me. But base angles are congruent. What did I say? Congruent. You think equal. So 48 degrees equals 5n plus 3. So I'm going to subtract 3 on both sides. I know 45 equals 5n. And divide both sides by 5. 9 equals n. Now, it just wants me to find the value of the variable. So once I have n, I'm done. And it's the same thing for 7. And it's the same type of problem for 9, although we are talking about diagonals in 9. But remember, the diagonals in an isosceles trapezoid are congruent. 13 down here. You know, I can do another one of these. Let's do number 10, just to kind of help you with this mid-segment problem that you have for 11. Once again, I have two sides, and I know that this side is half, or the average of these two. So we have x, and let me pull this over so I can see, x minus 6 plus 2x minus 9 over 2, and that's going to equal just plain x. Can I help you? There's one right up there. Where are you going to be? Okay, would you please return it? Okay. So to get the 2 out of the denominator, I'm going to multiply by 2. So I have 2x here, and this becomes 1. So 1 times this quantity leaves me with that quantity. Combine your like terms. So here I have an x and I have a 2x. That gives me 3x. And I have a negative 6 and a negative 9. That gives me negative 15. And that all together equals this 2x over here. So I'm going to add 15 to both sides. and I'm going to subtract my 2x on both sides. So then I know x, 3x minus 2x is just x. Negative 15 plus 15 is 0. 2x minus 2x is 0. And then I have a positive 15. So right there's your answer. That length of that side, the green side, is 15. Oh, I'm sorry, I pulled it down. And I hope that helps. You just really need to practice those types of problems. And fortunately for you, you have 2 that you can do, 5 and 11. And if you really felt ambitious, you could do 12 as well, because it's really important that you be comfortable in doing those types of problems. Let's look here at 13, though. And this is the same type of problem, but remember, if you don't draw the picture, you're going to have a hard time. The midsegment of a trapezoid. Well, what is the midsegment? It is the line that goes right down the middle, and remember, these two sides are those two pieces are congruent, and that's congruent because we make the midsegment by connecting the midpoints of those sides. It tells me that the midsegment is 16. And it wants you to list 3 possible pairs of lengths for the bases of the trapezoids. So you would say you'd have to find 2 numbers that when you divide it in half gives you 16. So what are some, basically what I want is I want to find something. If I divide 16 by something, oh wait, hang on a second. I multiply (16) is going to equal whatever those possible additions are going to be divided by 2. So to get rid of that, I'm going to multiply by 2. So 32 is what I have to have numbers that add up to. So what are 2 numbers that add up? 3. I said 3 numbers that add up to 32. Well, we could have a side that was 30 and a side that was 2. That would be one set. What about another? We could have 16, let's say 18, and 14. Wouldn't that be 32? Can you think of another one on your own? Think of 2 numbers that add up to 32, and that would be your choice. Let's do this side now. Now this is our kites. This is all the kites. Once again, you guys are going to be doing odds, but like I've said, I'm going to do a lot of the evens here. In number 14, we are given a kite. Now I know it's a kite because it has 2 pairs of congruent sides that are consecutive. They're not opposite of each other. They are adjacent to each other. I know that because they gave me these marks. Now I want to remind you about something here, although this doesn't particularly help you in an extensive way. But I want to remind you that right here, if I marked this, that side would be congruent to itself. So I have 2 triangles. This triangle is going to be congruent to this triangle because of side-side-side congruency. So we know that this whole angle is going to equal this whole angle. This line lines up, so 1 and 2 are going to be the same. We also know that this angle and this angle have to be the same because when I fold them, they're going to match up. So if this side is 18, this side is 18. Now, you might want to just identify the triangle you're particularly thinking about. So here's this triangle right here, and this is the one they're talking about. One of the things you also have to remember is that in a kite, these diagonals are perpendicular. So I know 2 angles in this triangle, and what can I do to find the third? Well, the measure of angle 1 plus 90 degrees, because that's this angle, plus 18 degrees is going to equal 180, because this is a